Assalamualaikum and hi everyone. My name is NURSYAZANA binti HUSSAIN. Today, I will present about my final year project entitled Simulation on the Stress of Steel Arm of Triboelectric Generator. In this slide, I am going to share about these 5 things that is crucial in my FYP report journey, which is starting with introduction, literature review. The third one will be research methodology, and followed by results and discussion, and the lastly will be the conclusions. So let's get to the introduction. Do you guys ever heard about the triboelectric generator? So the triboelectric generator is a newly developed technique for harvesting mechanical energy from surroundings and convert it into electric power. The source of this mechanical energy can be obtained from human body motion, such as hand touching and walking for triboelectrification. This triboelectric generator device is set up with different charges of material, thus the electric power is generated between the surface. The cost to fabricate it is cheap as it doesn't require bigger size. The bigger the generator, the greater the energy output. So, the main objective in this research will be to design a model of triboelectric generator using SolidWorks or Autodesk Fusion 360 application. And the second objective is to simulate the effect of different thickness and force applied on steel arm of triboelectric generator using SolidWorks or Autodesk Fusion 360 applications. So triboelectric generator as a new source of energy. Why? So, in this new era, people are keep demanding for more renewable energy in order to keep up with the IR 4.0. So, the most important thing in the triboelectric generator is a triboelectrification. So, what is a triboelectrification? Triboelectrification is an effect that exists widely around the world. It is among one of the important fundamental principles of triboelectric generator, which creates static polarized charges. In the assembling of triboelectric generator, there is always two different materials installed side to side, touching each other. When these materials are attached, opposite static charges appear on the surface due to contact electrification. The triboelectric generator is believed to be low weight, large output capacity, high performance, and also easy to manufacture. There are several fundamental operation modes available, but most of the operation could be summarized to have 4 important modes, which are, as shown in Figure A, are attached electrode contact mode triboelectric generator, and for the Figure B is the attached electrode sliding mode triboelectric generator. And for Figure C is single electrode triboelectric generator, and the last figure will be the freestanding triboelectric layer-based generator. So before I proceed, I am going to explain a bit about these fundamental modes. An attached electrode contact mode triboelectric generator is defined as the periodic change in the potential difference caused by the cyclic separation and recontact of the opposite triboelectric charges on the inner surfaces of the two sheets of organic or inorganic materials. As for the figure B, is the attached electrode sliding mode triboelectric generator is a typical attached electrode as shown in the figure. When a natural touch and lateral sliding occur, two regular friction forces are present. Based on in-plane sliding between two materials with distinct tribopolarity, triboelectric generator can be manufactured. The periodic change in the surface contact area is caused by intensive triboelectrification induced by sliding friction. The figure the fig, in the figure C below, the materials will be attached to two electrodes. However, this design has some limitations that will affect the application of triboelectric generators because the moving object of this practical application does not belong to the device system. For the last figure is the freestanding triboelectric layer mode is used to harvest mechanical energy from arbitrary moving objects, such as humans. The triboelectric generator The triboelectric generator mode is generated on the basis of a freestanding triboelectric layer sliding between two stationary electrodes on the same plane. Moving on to the methodology part. These are the designs that I am going to use for this entire simulation process. In this simulation, the force applied will be varied by 5 Newton, 10 Newton, 20 Newton, 30 Newton, 40 Newton, and also 50 Newton. And for the thickness of the steel arm is 10 millimeter, 12 millimeter, and also 14 millimeters. And the dimension for the other plates remain the same. Due to some laptop problem, I cannot show to you the whole picture of simulation for each force, but I did manage to say for 5 Newton force. From the picture shown, we can see that the stress will be small if the thickness of steel arm is high. So for the figure, first is the maximum stress produced with the thickness of 10 millimeter, and for the second picture is on the thickness of 12 millimeter, which the maximum stress is 1.258 megapascal, and for the last one is the lowest maximum stress, which is 0.6814 megapascal, because of the thickness are quite high compared to the others two, which is 10 millimeter and 12 millimeters. Here are all data that I gathered for every thickness in each force, starting from 5 Newton to 50 Newton. Based on the data that I obtained from the simulation that I run in the Autodesk Fusion 360 application, I believe that the greater the force load onto the surface, the higher the stress developed, and it will affect the deformation of the device, especially on the arm of the steel device. From the tabulated data, I have come out with two different graphs, which is force versus stress in the unit of megapascal, and also force versus displacement in unit millimeter. The blue color line indicates 10 mm thickness, orange color line is 12 mm thickness, and gray color line is 14 mm thickness. From this graph, it shows that 10 mm thickness creates bigger stress and displacement changes compared to the both dimension, which is 12 mm and also 15 mm. I purposely gathered the whole stress in one graph, and for the other graph is the whole displacement, so that it is easier to see the difference for different thickness of the steel arm. So for the conclusion, I came out that the simulation that are run in the computer are completely done. The parameters that we want to observe are all taken into account, and the result is taken and tabulated to see the pattern. Based on the result, we believe that arms with higher thickness, which is 14 mm, are much better compared to 10 mm because it can withstand higher force, and the maximum stress are much less compared to other dimensions. The displacement that obtained from the computer-generated simulation for 14 mm are not so high compared to 10 mm and 12 mm. This shows that the thicker the steel arm, the more stable the device and not ruptured easily. Thank you for watching my video.